Imagine you have the world's most secure vault. Inside it are your database password, API keys, cloud credentials, and certificates. Now imagine anyone could just walk up and open it. That would be a disaster. This is exactly why HashiCorp Vault has three foundational security concepts: authentication methods, roles, ACL policies. If you have ever been confused about how these fit together, this video will make it crystal clear. Let's dive in. Think of Vault like a highly secure office building. Before anyone can enter, first they must prove who they are. Then Vault decides what identity they belong to. Finally, Vault determines what they are allowed to access. These three steps correspond to authentication, identity, authorization, or in Vault terminology, authentication method, role, ACL policy. Let's understand each one. Authentication answers one simple question: who are you? Vault supports many authentication methods because different applications authenticate differently. Some common authentication methods include token authentication, app role, Kubernetes authentication, AWS IAM authentication, Azure authentication, GCP authentication, LDAP, GitHub OIDC. For example, if an application is running inside Kubernetes, it can authenticate using its Kubernetes service account. If a workload is running on AWS EC2, it can authenticate using its IAM role. If a developer wants access, they may authenticate using GitHub or OIDC. The authentication method only verifies identity. It does not decide what secrets can be accessed. That comes next. Once Vault knows who you are, it needs to map you to the permissions. This is where roles comes in. Think of a role as a bridge between authentication and permission. For example, suppose a Kubernetes pod named payment-service authenticate with Vault. The Kubernetes authentication methods verifies the service account. Vault then checks which role is the service account mapped to. Maybe it's mapped to a role called payment role. That role contains configuration like which Kubernetes service account are allowed, which namespace are allowed, which Vault policies are be attached, token TTL, renewable token settings. The role itself does not contain permissions. Instead, it attaches one or more ACL policies. ACL stands for Access Control List. This is where the real authorization happens. Policies defines exactly what actions are allowed. For example, the policy may say the application can read database credentials, read API secrets, generate dynamic database passwords, but it cannot delete secrets, modify policies, access secrets belonging to another application. Here is a simple policy example. Notice how permissions are extremely granular. Instead of giving full access, Vault follows the principle of least privilege. Applications receive only the permission they absolutely need, nothing more. Let's see the complete flow. Step 1. A Kubernetes pod starts. Step 2. It authenticates using the Kubernetes authentication method. Step 3. Vault validates its service account. Step 4. Vault maps it to the payment role. Step 5. The role attaches the payment policy ACL. Step 6. Vault issues a temporary token. Step 7. Using the token, the application can read only the secrets allowed by its policy. That's the complete authentication authorization flow. To summarize, authentication methods answer who are you, roles answer which identity should you receive, ACL policies answer what are you allowed to do. Understanding these three concepts is the foundation of mastering HashiCorp Vault. In the next video, we will explore how Kubernetes Auth works internally, how Vault validates service account JWTs, and how applications securely retrieve secrets without storing any long-lived credentials. If you found this video helpful, don't forget to like, subscribe, and share it with others interested in DevSecOps, cloud security, and HashiCorp Vault. Thank you.